Good afternoon, everyone. Welcome to the September Indicator of Behavior Subproject meeting. My name is Charlie Frick. I'm the chair of the subproject and your host for this call. Uh, Thought we'd kind of dive right in with addressing some news. Those of you that are on the IOB listserv or other Open Cybersecurity Alliance listservs may have seen the notification this week that OCA is currently in a state of potential transition. I know that there was a message sent out stating that by November, the current chair organizations will no longer be members of OCA. And if we do not get a organization to sponsor OCA and take that chair position, then OASIS will consider stopping the project. If that happens, we are working a transition plan for indicator of behavior research. Just wanted to let everybody know that if anything were, if we won't know for certain until November, but if anything occurs and the Open Cybersecurity Alliance as a open project stops, then we will make sure to get some messages out to everyone from our mailing lists beforehand so that you'll know where to find our newer updates to indicators of behavior if that happens. But we're not stopping this project right now or anytime soon. So I just wanted to kind of make that blanket announcement. And if anybody had a question, I'm glad to field that, or I can just kind of get into some of our new updates with IOB. All right. In that case, I'm going to start sharing my screen and talk to you a little bit about what we've been up to and have a few items of discussion for uh, some concepts that we would like to try out and going to be driving some of our research towards in the future. Moment, please, to gather my Zoom screens over here. That way I can track and see if anybody's got questions. Appreciate everyone's patience. Okay, so I'd say the first thing we wanted to mention is we are in the process of sending out some messaging on this topic. Apologies that I haven't gotten it on the Slack yet, but I will do that. We have a minor update to our reference implementation. So revision 4 is now live. So if you go to the IOB repository on GitHub, under the reference implementation bundle, we have a revision 4, which has updated a few things, trying to clean up to better, have a little bit better compliance with the standard, but also we removed some deprecated fields such as the old data sources field in the detection object. That said, this would be where you can get the latest information as well as a little summary report to help provide you some guidance on what we've done there. What I think also might be of interest in this folder, we now have a example called Living Off the Land. And what we've done is we've been running a series of integration tests here in our development environment at Johns Hopkins Applied Physics Lab to test out how we could use indicators of behavior to represent living off the land attacks. So some of you might have been familiar with the very large Volt Typhoon campaign. You may have also seen our very smaller example that we called Spark Rainstorm a while back. But what we've done is look at those combination of living off the land tactics, techniques, and procedures. And we've built out we did some threat emulations, some research into detection engineering, and we built a sample indicator of behavior bundle to represent all of that. In our last IOB call, I believe if you pull it up on YouTube, we did a little preview of some of those items, but now you'll be able to download the IOB bundle as this JSON And similarly, it's got a nice little write-up to provide you with information on the various elements. So I wanted to just let everybody know about that. And before we dive into our more technical talks, I wanted to see if anybody had questions about that. Okay, so during some of our last calls and some of the conversation that's been happening on the Slack, we've seen a couple of areas that we'd like to focus on IOB, and I'm going to talk about them today. One of them is looking at malware behavior representation, as well as talking about what a potential concept that we're calling a decision object that could be better used to to describe what triggers a course of action. As I think everybody on the call right now is familiar with, we often use this little Python script here on our GitHub, the sticks to Neo4j converter, to convert the IOB sticks bundles into graphs because we find that the sticks 2.1 format is naturally well suited to a knowledge graph. And so we like to use we use a graph database, Neo4j, in our internal research. And I'm going to use that today to talk a little bit about this concept. So we're going to start off discussing the malware idea. And I'm going to try and blow this up a little so that it might be a little bit more readable. Now, it's more than just one object, but I thought I'd start there and kind of help, showcase how we're looking at this problem. So Sticks contains a standard object for reports. So we're starting with and by the way, this is a fictional malware case that I'm just using for examples today. But this would be a report on a fictional piece of malware called Dark Hydra. And you can have a description of your report. You could have the full name. You could have references to everything's in there. You also could include URLs to go to a larger PDF version, or if you wanted, you could embed the entire report into the object. But we thought that'd be a good way to start on how we would build out a indicator of behavior bundle for malware behavior. So if I expand out the relationships, I'm going to hide this. You'll immediately get a few things sent to the report. We have an identity object, says that the OCA made this. I'm going to hide that, and I'll probably do that a few times. It'll pop back up as I expand out some of these relationships. But from our report, we have ourselves a malware object. And so the Dark Hydra report is about Dark Hydra. Traditionally, you'll have indicators of compromise in a lot of these reports that were used to indicate this, and some attack patterns are normally associated with the report, as well as a threat actor object. So this is just more standard, very standard sticks representation at the moment, but we can say that, well, these reports often say there's a piece of malware, and we attribute it to this threat actor. And here's an IP address we saw it used in the wild. Here's a file hash. Now, that's not always the most useful, actionable data long term, because we disseminate these reports, and eventually, that threat actor, normally very rapidly, they're going to modify the malware to have a slightly different file hash, and they'll most absolutely change the command and control IP addresses or domains even. But we normally publish these reports, and then we want to have a few attack patterns. And one of the things that we've been working on is showing that MITRE developed a very nice, similar to attack, more complementary to it. MITRE also developed a malware behavior catalog. And while I do like the name, it's a really good taxonomy to describe various behaviors of malware. But kind of similar to attack, it's living at a little bit higher level than what I think we might want for detections. So just doing an example here for the read pipe object, it is, you know, it's C003.003 in there. And if you were to look that up in the malware behavior catalog, you see that it says that read pipe behavior is reading pipe from inter-process communication. And the inter-process communication micro behavior focuses on inter-process communication. I do appreciate the taxonomy, but I would contend that this might not be quite enough information to really help us, whether we're working on rules for security operations teams or tailoring analytics for EDRs or other tools. This probably isn't quite specific enough to really help us in detecting something like this fake dark hydra. So I'm going to show what we're recommending. So allow me to expand some things out, and I'm going to make this a little bit cleaner. And you'll see already, I'm going to get to that in a moment, but another report has creeped up. All right, allow me to hide that identity object again. And while these malware behavior, elements are nice, what we're going to do here, and I'm going to move this thing called Iron Wisp all over here for a moment. But we can have our behaviors. Let's see. Let me, similar to what we've been doing for describing threat actors, we can really get into a little bit more detail. And for the elements we're seeing in the malware behavior catalog. And let's move these over so they're lined up the right way. So what we're proposing is, as you use various malware analysis tools, sandboxes, malware analytics platforms, reverse engineering, I know some of our research here at the lab orchestrates a whole suite of those capabilities to help capture the different behaviors. You can map those not just to the malware behavior catalog, but I would contend that we could actually grab a little bit more data. So let's just look at that read pipe malware behavior. We know it's reading a pipe in inter-process communication. Well, maybe we can be a little bit more descriptive with respect to this piece of malware that we're calling Dark Hydra. And so we can say this occurs when a user context process repeatedly opens and reads from a Windows named pipe, transferring small chunks at sub-second intervals. And a little bit more descriptive of what this piece of malware is doing. And that can be used to develop detection rules. And I'll show an example of those in a moment. But additionally, if we start looking at sharing this type of data in a machine readable format from our malware analysis, we can also begin very rapidly building out a catalog of these behaviors. One of the areas that we're very interested in taking IOB research next is how we can actually start using some machine learning as well as some large language model trends in how these behaviors are described to automatically build out some candidate behaviors. Because what you'll see is certain behaviors will get reused, and we can find more malware samples that'll have the same, that'll also have maybe not the exact same set of behaviors, But when we see they're similar to each other, we can see certain behaviors are going to happen the same way. And it might have some additional elements. I think I made a little mistake here and missed a relationship. So I'm going to try and fix that. And my apologies. It should have been a Sigma rule associated with this behavior as well. And this could be built out to have more and more data. And in this little fake example, we've actually got these associated to the same threat actor. Oh, wow. But the idea here is, as a community, we can use this to start looking at how we can share analytics for common behaviors within bits of malware, so that as you start doing similarity analysis between new samples, lots of times the attackers are reusing parts, take a couple pieces of one malware and use it to make another. And this makes it a lot easier for us to start sharing kind of analytics for those piecemeal parts, so that we could say, hey, these are the type of rules that we might want to put into uh, threat detection for malware. That could be email appliances, could be EDRs, could be a SIEM. Um, and so showing that now, instead of just saying, this is inter-process communication, we could actually build a little bit, let's see, we could build a little bit more specific type of analytic, and we're using Sigma. Quick disclaimer, this was an example I was just making to describe the IOB structure and how it could be used to represent malware behavior. I am not claiming this is a terribly good or even accurate Sigma rule. I just wanted to embed some to show the idea that we could start describing the analytic to find that behavior and say that that detects process reads from a named pipe and user session, from inter-process data transfer, and actually gives some description of what we're looking for. A lot of product vendors, this is the way that they've been looking for malware behaviors for a very long time. But if we want to think about how we can improve community sharing, this is a way that we can start having and building user-generated content to help design those custom rules more rapidly by adhering to a standardized interface like STIX 2.1. This gives the ability for our vendor support to improve their interoperability and allow people in a more vendor agnostic state to provide more intel to those vendors. They have their own threat intel teams, but this is a way we've already seen for many years that no one organization is going to capture all the threat intel. No one's going to get all the malware in the world. This is a way that we can have researchers and defenders publicly share much more actionable data. And if our vendors adopt interfaces for these standards, then they can rapidly ingest and test these analytics into their platforms. And so that's just a little bit on how we were seeing things, potentially work for malware. And oh, sorry, didn't mean to hide that one. But anyways, are there any questions on what I'm talking about here? Because I've been talking for a bit and I want to see if any other folks have thoughts on this. Okay. Now you'll notice that in this example, I didn't add a playbook or a course of action. We could do that too and look at ways that we might want to automatically address bits of malware. But I thought I'd start with what I thought seemed missing in a lot of publicly shared malware reports normally is this a little bit more actionable level of detail. But just like MITRE ATT&CK has been a great taxonomy for, adversary actions, I do think that there is a lot of mileage we can get out of these malware behavior catalog elements that also exist in a large STIX repo. And so I wanted to kind of push that concept out there and just see if there were any thoughts on how we expand upon this. I will take silence as you said a lot, Charlie, and we're thinking about it, but just wanted you guys to kind of see this concept so that you can think about this is one of the areas that I think we can make a lot of progress in with IOB, building out tools to start rapidly generating large numbers of behaviors and better describe what's happening rather than just have the tag and have a couple indicators of compromise. So that was one of the concepts that I wanted to take some time today to talk to you about. Yeah, Carter, do you have a question?
Yeah, so this is I mean, this is really interesting. But how long did it take you to set up this? The notion that you understood that there was a relationship between these two malware strategies. So in some ways, just putting together the demo is an indication of complexity and reusability and things like that. Did this take a long time for you to put together?
For me, took me about, I think I'd say about 2 hours.
Oh, that's not much at all.
Yeah.
And do you sense that there are dozens of these or hundreds of these or a handful of
I
these?
think we're in the high dozens. I think we're in the high dozens, but and now I built this by hand. I will say there are, here at the lab, there are some automated malware analysis suites that can, in a matter of minutes, generate pretty much everything you see here except the detection analytics and the behaviors. So there are automated tools to help map things out here. And what they've done is they are embedding lots of descriptive text in the reports. And that's where I think is a potential like gold mine for how we can mine that and really start filtering these down into a set of repeatable behaviors that I think are in the high dozens and feed thousands of samples through it.
Yeah, the practical approach to the graphs, it is slightly cumbersome. I mean, you do this a lot, but it's still, but the relationships seems like that could be automated pretty quickly, and we actually discover quite a lot of relationships. Have you thought about turning on the automation onto some kind of big chunking set of data and see what you got?
Yes, I have. And that's why I'm saying it's a big area of interest for us, because hopefully in the next couple of months, we'll be getting to start some more focused research specifically on this problem.
I think this is pretty cool.
Yeah.
Charlie, just a question. What data sets have you got?
So now this one, like I said, I made two purely artificial examples just for today's talk. But for the data sets, there's a variety of public and private malware repositories that we have access to here at the lab. So that's what I'm hoping to do our next wave of research on. I mean, I don't remember the exact count, but we have thousands upon thousands of samples that we've been analyzing over the years. And so different styles, and want to kind of test those out in some of the more automated pipelines and see if there's something there for generating this type of these type of graphs at pretty large scale. And if so,
any data, I mean, is there a large quantity of data in the public domain, or Is it most
Um,
diameter?
there are some good public. Uh, the zoo had a lot for a while, and there was the Contagio dump site that used to maintain a big set. And I know there's one or two other ones. I will ask my more specific malware team here at the lab. That was Brian that asked the question, or is it Larry? I couldn't tell who asked that, by the way.
It's Brian who asked
Oh,
it.
hi, Brian. Hi, Brian. Um, I'll see if I can capture that, and if I can find a couple of those links for the malware repositories, Brian, I'll put those in the meeting minutes and distribute those out later this week.
There we go, Charlie. Thank you.
Yeah, absolutely. Of course, since this will go up on YouTube, I will say any of the sites that I'm saying, please understand I'm talking about archives of live malware. So they're normally standard practices to encrypt those or have those as encrypted zip files. But please know that if you do decrypt a malware binary and run it, you're running a piece of malware. So you really don't want to do that on your personal computer. You really want to execute those things in the lab. I'm sure everybody on this call, this is common knowledge, but I figure since this goes out to a public audience, I should do that little public service announcement of if you download malware from a repository, don't run it on your production or actual machines because it's malware. All right. Any other questions along this concept? I will say we don't have them on the call right now, but there have been some EDR vendors that have been discussing this concept with me that I'm hoping if we're able to start building some things out, we might be able to get some collaborative research and maybe even potential future pilots going to showcase what's happening here. And I will give an update on, and I forgot to say in our general news up top, I'll give a small update on our ongoing indicator behavior production pilot with Hudson Alpha Institute for Biotechnology. But I'll finish talking about some of these new STIX concepts that we want to do with IOB. Before I move on, are there any other ideas on this malware behavior concept? Okay. So another case that's come up is something we noticed when in previous behavior bundles, we've shared lots of, detections, and we've currently been using STIX grouping objects to group the detections and map those to courses of action. Now, visually, that makes a little connection, but really, there's still not really information there to tell a machine when to execute the course of action. And so one of our previous discussions had this idea come up, and credit Brett Forbes from OS Threat. I don't think Brett could be with us today because he's out in Australia, and if I'm doing the time change right, it's somewhere like 2 to 3 in the morning out there. But brought up this idea that maybe we want a decision object. And so this is going to be a very simple example that I'll share with you guys. But instead of using, so this right now, here is originally our little baby Spark rainstorm example. And this is also the example I use in the sample curriculum for how to create and use indicators of behavior that we have on our GitHub as well. But this is a computer running executables from abnormal locations. That computer using the PowerSploit, PowerView, PowerShell modules to conduct reconnaissance, and the ntds.dit file being copied off an Active Directory server. So, and previously, we'd had some detections for those, and we'd put them to our grouping object, and we'd map that to a correlate and score score behaviors, course of action, that then would have something like an embedded Cacao playbook. Well, what was missing by just having a grouping is it never said, when do we do that? So this is where we had the idea that our detections and needs might be, right now I used a relationship called needs. I made that up. It's probably a bad idea and probably could use a better word. I just kind of wanted to show this first concept because what I'd like to do is start getting more discussion through our community on how we might want to collaboratively design this. But I feed all these to a decision object. And this hasn't been put into our reference implementation yet. This is really a extremely simplistic schema just to say, what if we had an object that represented a decision? And so detection of behaviors will generate some data or not, and they can feed a decision and say, if, in this case, if a detection triggers an alert, start the correlation course of action. If it does not, do nothing. And this was a conversation you and I were having, Carter, that do nothing is a really important course of action when you want to start feeding stuff to automated agents, because we don't always want them executing everything in a big flooding pipeline. But obviously you could have a few different course of action. Maybe we'd have one for increased monitoring. And maybe this decision object is, are there more than one detections firing in a certain time window or from the same machine? And this could become, we could look at a few options on how we want to describe that decision logic in a much more robust form than my simple like one sentence description here. But I'll stop there for a second, but this is like the overall concept. So actually I'll say one more thing, and it came from a conversation you and I were having, Brian, that there could be options here too to have some way to represent risk as well. Oh, can everybody see my screen? Have I been talking to a blank screen for a while?
No, you're good.
Oh, okay. Just verifying. Because I was going to feel really dumb if nobody's seeing this graph that I've been pointing at for the last 5 minutes. But it's saying like we could embed a much more complex set of logic here. And I'm really open to ideas on how we might want to design that schema to represent a decision point. But I think this could be a nice way to represent, say, triggers for Cacao or other things. And I know the Cacao spec is working on some additional changes, and I think it's revision 3 to,
Sorry,
I don't
it
know.
must be me, but I can't see your screen.
Okay, but others can. I'm just verifying again. Carter, you said you saw that, you're seeing the graph?
Yeah, I can see it.
Okay.
I can see it.
Well,
Okay.
Okay,
Sorry, Brian.
no problem.
I assure you the graph is beautiful and
Big beautiful graph, I firmly believe it.
very aesthetically pleasing with my use of primary colors. No, but actually secondary colors. Anyways, so I guess I kind of want to just open up the floor for a moment for some thoughts on, do we like this idea of making this type of object? And would folks be interested in maybe continuing this conversation a little deeper over the coming weeks and months on how things that we might want inside a decision object? So just in general, what do you guys think?
So are there action objects that would cover most of what would be the outcome of most decisions in these sort of paradigms?
So my idea would be that the decision would decide on a course of action. And so that would be your action to take. And that your course of action can have a machine readable playbook to execute it.
So all the complexity can just be in the course of action.
Yeah. but deciding whether to do it. Or if we wanted more complexity up front, you could do that. But we might want to keep these simple, because I think a lot of times it might be do something, because a playbook successfully correlating, that can also feed a new decision. Where we stop and do nothing, or where we go begin an incident response or machine mitigation or threat mitigation workflow.
Do you assume logging is going on for all of these decisions?
In this example, yes, but it doesn't have to be logging.
But you wouldn't necessarily suggest that log the decision as a part of the course of action.
No, I think this could feed other automation.
Okay.
It doesn't have to be logged.
That was my next question. What would, well, I can't see the decision object, but what would consume a decision object?
So right now, a detection object would consume. Oh, sorry. Like what type of tool? Forgive me.
Yeah, exactly.
Yeah.
What kind of decision engine?
So I tend to think in terms of SOAR, but I could see this in an intrusion detection system, a network auditing system, endpoint, but I tend to have security orchestration on the brain. So I can also think, of processing pipelines like NiFi. These could be like simple gates to decide whether to do other automation management.
And how would you encode it? Cacao or?
So that's where I was getting at. It's like my first thought was Cacao again, but I'm not sure yet if we have a better logic standard that we'd want to use. I'm not. So that's an area that we're probably going to be playing with and experimenting with, but I'd like to kind of get multiple people's thoughts on how we want to do that. And I think Brett Forbes has been going into a little bit of this idea on the IOB Slack. And as we start to experiment on this, I'm going to see if maybe we can try a couple of the use cases he put out there. At the second, I'm not going to do them justice. But
would you be willing to consider AI accountability or verified AI using these kinds of decision elements?
I mean, that I would like that. And in which case we might want to also see how we can do this in a somewhat technology and protocol agnostic way, because I think, Carter, you're saying that we'd want to feed these to little AI agents.
Well, the AI agents will be making decisions, and just for them to use this strategy to account for their decisions, or feed into a decision verification system or some sort of assured AI sort of system where I need to see what decisions you're making and why, blah, 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 blah.
I think that's an extremely good use case. But it's somewhere we have to give this logic, I think. Mateus.
Hi, Charlie. I'm wondering, so you're talking to use AI inside the decision object, or that AI
No,
use
AI would use these.
Okay. And how are we going to make the decision? Is it the STIX patterning language or what?
That's part of what I was trying to decide. If STIX pattern, that's the area that's still kind of up for debate.
You have inputs, right? So those inputs can be for sure represented by STIX patterning, and then it's quite simple logic right now that this is true, then we are doing this decision. This is not true, then we are doing that decision. So it's fully deterministic, which is fine. But yeah, I'm wondering, yes.
Yeah. So I think there's a couple. I think STIX pattern should be an active thing that we try, and see if we run into some cases where it might be trickier.
Mm.
I like it.
And regarding Kakao playbooks, right now, I think we are still leaving the triggers outside of the spec.
Okay.
Yeah.
Forgive me, I couldn't remember if that was part of 3 or not.
Yeah, well, I would like to have them,
Hmm.
but right now I believe we are writing that this is like the orchestration work, not the Kakao specification.
I understand.
Hmm.
So did someone have a hand come up? Forgive me, I thought I saw something for a minute and
I think that was mine. I just lowered it back
oh,
down.
you lowered it. Okay. My peripheral vision's tricking me. So are there any other thoughts or questions on kind of the decision on this decision object besides the fact that we still need to flesh this out more? I know this is an extremely raw concept, but I wanted to put it in front of all you guys to see if it's a horrible idea. This was a great time to learn that, but it seems like this is an idea we should be pushing a little bit further.
So if the decision is to select from a list of possibilities,
Hmm.
this is really quite straightforward. I think it's really good. But if so, in AI, the emergent behaviors are, new decisions, new results. That description may be really cumbersome and very difficult to capture at first. But I think just selections of, like predetermined decisions looks like this should be able to do a pretty good job.
Yeah, and I think that'll capture a lot. Emergent and new decisions and making new courses of action. I'm not sure yet. I think we could see about a way to store some of that eventually. And hopefully we're not making tons of brand new types of courses of action and decisions. They might be implemented slightly different. But okay. Well, in that case, I'm going to stop sharing. And I do owe you guys a minor update. So as I've mentioned in our last call, we have been executing a operational pilot for, we'll call them traditional indicators of behavior at the Hudson Alpha Institute for Biotechnology down in Huntsville, Alabama. That is still underway. Just nature of pilot, sometimes we're moving a tiny bit slower, but we currently have indicators of behavior down in their production environment, along with a suite of network sensors, some endpoint logging, and some basic Kakao playbooks that we've been using an early version of the Sorka open source orchestrator. Some things have worked really well for us. Some things have been a little challenging. But I wanted to let everybody here know that the indicator behavior bundles, metrics from the performance, the Kakao playbooks we're developing, we're all working on having a, scrubbing through and removing any potential proprietary, like to Hudson Alpha's network. We'll pull those out, but maintain a public set of the IOB bundles, including detections and playbooks and courses of action, as well as some shareable metrics from executing some of this. And these particular ones are tailored to find cyber threats that are targeting biotechnology and genomic data. But I think this could be a nice operational use case that we can kind of share publicly to say, hey, somebody tried this on their network. It didn't break their network. It didn't break their SOC. It didn't flood them with notifications. I can share in testing, we've seen some of what we thought we would see of individual detections sometimes having a little bit higher false positive than what we'd want to put in front of an operator, but correlations having a very low false positive rate. And that's kind of the entire intent on why we were developing IOB as a bundle of detections to be correlated in the first place. But just thought I'd share that that is coming along well. We are seeing some good progress. And as soon as I have that, we have that wrapped up, we'll begin working on some publicly shareable technical reports, as well as maybe some a little bit higher level miniature white papers to share amongst our community, just to kind of talk more about this concept and help drum up more interest and support that for having the technology interfaces for IOB and even better support for things like sticks, so that we can maybe get more products or open source offerings out there to people. Any other questions regarding that?
Charlie, let me add a little bit to that. I'm running a project on the Horizon Europe cybersecurity project. And so one of the things we want to do is we've got pilots as well, 3 different partners in pilots, but between 2 of them, we want to share IOBs. Now, it's difficult in a project like this to try and get everyone on board and everyone coordinated and everyone doing the same thing. But basically what we're doing is we're using Atomic Red. We've looked at the attack flow and stolen, if I can say stolen in inverted commas, some of the attack flows there greatly simplified, and we've replicated a few of them approximately, I will say, using Atomic Red. So we want to generate the data using Atomic, and then we've got a small test bed set up, much like you have in your original. I mean, the idea here is really dissemination rather than innovation.
Yep.
We're making progress with that. I'd like to come back, at a later date when we've got things actually running and we could show something.
I would love that.
We are intending to try and say spread the good news. Basically, that's the aim, and we hope to start the pilot sometime in early Q1 next year, January or so. But I can come back once we got something more complete. But just to say we are doing something in this direction.
And I think we should be able to convince all of our employers that we should see that demonstration live in Ireland with you, Brian.
Of course, yeah. Better one of the partners is Italian, one was Spanish, so we could, definitely.
Then I think we need to get some Euro passes and just got to go all around, and we'll get.
When I've got more complete, something worthwhile showing, I'll come back on that.
Absolutely, just reach out to me whenever, and we will absolutely schedule a demo for you. And I love it because I'd like to see, like, I do know the threat emulation is a challenge for a lot of folks, so I think Atomic is a really good solution for that. One of my problems was whenever I had to start modifying the test in Atomic, I started getting into a bigger and bigger cascading complexity problem.
We looked also at what's the MITRE tool? Caldera, but it's just too complicated, and you can't actually do multi-step. Caldera 4, we figured out how to do it eventually. Then they changed it completely in Caldera 5, so we just abandoned it. Probably we just didn't have enough time to work with it. And I guess one of the things with Atomic is it's very hard to get a very coherent. You can't emulate a full test because it's difficult to actually have the movement from one machine to the other on the phone. But I guess the idea with microemulation as well is maybe to just discard some of the early stages of the attack and focus on, let's say, lateral movement or some specific parts. So
which can be good.
Microemulation philosophy, basically.
And that might speed up some detection and that, detection work. And I can definitely see the value in that.
We've innovated a little bit in that we're using attack flow as we built a state machine around attack flow, and we've written the correlation in attack flow.
Interesting.
Anyway, we can get to demonstrate that at a later time.
I would love to see it, sir.
Okay.
All right. And did somebody else I thought might have came off mute for a minute if you had a question or a comment? All righty then. Well, I'll take one more pause to say open floor for a moment. Don't need to force you all here for another 8 minutes, but if there's any other questions or concerns that folks have, I'm glad to help field those. Otherwise, I'm going to work on finding some of those malware repositories for you, Brian, and we'll work on getting this recording and the minutes out there and published so everyone can read up on the good work we're doing. And then ideally, we'll be getting back together in December for the next one of these calls. And as I said at the beginning, in the event that that we might not have an OCA at that point, we will hopefully we'll have a new chair in place and the project can continue. But if not, we will be looking for other ways, and we'll reach out to all of you through the listserv and the Slack channel prior to anything going away, and we'll find some alternate ways to keep
Sure.
having these technical exchanges.
Perfect.
Yeah.
I have a quick question. First of all, I love your concept, but I am not the client, I'm consultant. So I need to convince somebody to participate. And how your pilot covering this concept, what you described today?
So the decision object, and right now the decision object we have folded as part of the logic in the course of action playbook. That's kind of how we were doing it in the previous revision. And so that's what we did in the operational pilot right now. Because before I wanted to use the pilot to just kind of suffering the same problem you're describing, Larry. I want the pilot there so I can actually write up some use case studies to put out there to say, hey, someone's actually using this, someone sees value in this, maybe you should do it too, and it's not that crazy, not that dangerous. So after we flesh out the decision object idea more, then I would be looking for another pilot to be able to demonstrate that piece. But the one at Hudson Alpha was primarily just to get somebody to publicly say, yes, we use this in our environment and we like it.
Okay. Thank you.
Absolutely.
And when you said schema for your pilot or concept, it's JSON schema.
That's correct.
Okay. Yeah. Thank you.
Oh, you're very welcome. Any other questions? Oh, Mateus, yes.
Yes, Charlie, I missed our last call, but could you please give me like super quick update regarding the Stix generator?
Yes. So the our Stix modeling tool.
Yes.
Good news is the code is ready. We are hours to days away from having the public release approval done. And then I have a couple outstanding tickets on just the final security check on all the packages inside it. And we'll be putting, as soon as we do, I'm glad you asked, because we'll be putting up that new revision publicly on GitHub as soon as I have the approval finished.
Perfect. Thank you very much.
It might still be a couple weeks to get the code review done.
I understand. I'm
But-
still looking forward to it.
You know that I think you can relate to some of the challenges of tracking down all the third-party packages and libraries.
Yep.
Exactly. But it has a few new features. One of my favorite ones that I will share is it gives you if something's wrong with a Stix bundle, it gives you a better summary of what's wrong with it, rather than just erroring out. So we took advantage of the Stix validator to help, and I find it handles extensions better. And then personally, all these years now of me manually dragging Neo4j blobs around, I'm grateful to have something that snaps the icons back to a grid so that it's a little easier to line up and clean up some of these graphs.
Perfect. Sounds good.
Yep. All right. Anything else for anybody? Okay, then. In that case, everyone, thank you all so much for your time, and I will stop the recording.
Okay.